Alright, chapter 5.6 deals with radical expressions. Please remember for the first part of this lesson that we are going to use higher degree roots, so third roots, fourth roots, fifth roots sometimes. And please remember the rules, because sometimes when we take the even power of a variable and we end up with an odd exponent, we have to make sure that that odd exponent is placed in absolute values to make sure that it stays positive. So first part of this lesson, we're just going to simplify some radicals. So if I gave you this long expression here, the square root of 81, p to the fourth, and then q to the third. Well, I'm going to go ahead and separate these out. I can go ahead and just make the square root of 81 times the square root of p to the fourth times the square root of q to the third. Well, the square root of 81 is easy. That is 9. P to the fourth, taking the square root of that, remember, I just simply divide my power by my root, so I get 4 divided by 2, so I get p squared. The square root of q to the third can get a little tricky. Imagine this is really the square root of q squared times q, okay, which is actually the square root of q squared times the square root of q. So what's going to happen is this q and the q squared, I'm sorry, the root and the squared are going to cancel each other out, giving me a q on the outside, and then what's remaining on the inside is going to be a q. Now, we could put absolute value bars out here. That wouldn't be wrong for the q. However, the book says, and it actually makes quite a bit of sense, that you don't need the absolute value bars in this particular problem because this thing must be positive. Therefore, this must be positive as well. Alright, so if you can follow that logic. If you want to stay on the safe side, just put the absolute value signs there. You will not get marked down at all. Alright, next, rad 98, y to the fourth. Let's go ahead and just expand this. I like to take roots individually. So I'm going to take the square root of 98, and I'm going to multiply that by the square root of y to the fourth. Well, the square root of 98 is really 49 and 2, so that is 7 rad 2, and then that is times the square root of y to the fourth is y squared. Since I was able to take the square root, that's going to jump into the outside, so my final answer is going to be 7y squared rad 2. Number 3, if I decided to do the square root of 8a to the fourth, b to the third, okay, similar to the first problem we did. Actually, you know what? Make this b to the sixth. Okay, I'm going to separate this out. The square root of 8 times the square root of a to the fourth times the square root of b to the sixth. The square root of 8 is 2 rad 2. The square root of a to the fourth is a squared, and the square root of b to the sixth is b to the third. Now, we're going to rearrange this because these are on the outside now, so I get 2a squared times the absolute value of b to the third, and the rad 2 stays on the inside, and that's as far as I go. So why is it important to learn how to simplify radicals? Well, we simplify rads so that we can combine them. And let me show you what I mean by that. Similar to how we have to have like terms in order to add and subtract terms, we have to have like radicals in order to add and subtract them. So if I say 8 times the cube root of 6 minus 4 times the cube root of 6, these cube roots of 6 have to be exactly the same. So I have 8 cube roots of 6, and I'm subtracting 4 of them, which means I have 4 remaining cube roots of 6. Okay, similar to if I was to add, say, 4 square roots of 2 plus 9 square roots of 2 plus 3 square roots of 7. Well, these two terms can combine to get 13 square roots of 2, but the 3 rad 7 has to trail behind because there's no like term for it to combine with. So let's take a look at some examples of how to do this. And again, this aspect actually should be very similar to what you've seen in Algebra 1. If I say 2 rad 20 minus 2 rad 45 plus 3 rad 80, all you have to do is reduce all of your radicals to their lowest radical and then see what can be combined and what can't be. 20 should be 2 rad 5. Don't forget, that is times 2. Minus 2 times the square root of 45 is 9 times 5. That is 3 rad 5. And then plus 80 is really 16 and 5. So that is plus 3 times the square root of 16 is 4 rad 5. So let's go ahead and just multiply some stuff out. I've got 4 rad 5s here minus 6 rad 5s plus 12 rad 5s. 4 minus 6 is negative 2, plus 12 is 10 rad 5s, and I'm done. Okay, let's take a look at another one here. Number 4. If I say 5 rad 20 plus rad 24 minus rad 180 plus 7 rad 54. So let's reduce everything. This is really 5 times. Rad 20 is 4 and 5. This is 5 times 2 rad 5 plus rad 24 is 4 and 6. So this is 2 rad 6 minus 180 is really 36 and 5, which is 6 rad 5. And then 54 is 9 and 6. So that would be plus 7 times 3 rad 6. So let's multiply what we can. 5 times 2 and 7 times 3. This is 10 rad 5 plus 2 rad 6 minus 6 rad 5 plus 21 rad 6. The rad 5s can combine, which is 4 rad 5. The rad 6s can combine, which is plus 27 rad 6. Not 27, sorry, 23. 23. All that work and I forgot. 21 plus 2. Okay, let me get set up for the next part of this. So that was adding and subtracting. It's time to move on to multiplication of radicals. Basically, when it comes to multiplying rads, the rule goes like this. You multiply the outside to the outside, and then inside to the inside. All right, and I'll show you what I mean by that. And also, part of multiplying rads means that you need to be flexible in your thinking. Sometimes it might be better to reduce and then multiply. In fact, that's usually the case. But then sometimes you have to multiply in order to get it into a position where it can be reduced. So I'll show you what I mean by that right now. If I was to say do 2 rad 20, this is example 1, times 4 rad 72. Well, I can go ahead and multiply 4 times 8, but for me to have to multiply 20 times 72 and then reduce it, that's just kind of nasty. So I'm going to reduce first. I'm going to say 2 times 2 rad 5 times 4 times, let's see, 72 is really 36 and 2, so that would be 6 rad 2. So I've got 4 rad 5 times 24 rad 2. Well, I know that the inside is going to be rad 10. 4 times 24 is a little nasty, but it's not as bad as 20 times 72. Well, 24 times 40 is 96. And that's as far as you need to go. Number 2, 3 rad 18 times 4 rad 28. Again, reduce first if you can. And so 3 times, let's see, that would be 3 rad 2 times 4 times 2 rad 7. So what I've got is 9 rad 2 times 8 rad 7. I can multiply everything. So I've got 72 rad 14. All right. Okay. Sometimes you're not always going to multiply single radicals. Sometimes you're going to use FOIL or the distributive property with radicals, and it's pretty simple. Let's see, if I say 4 times the square root of 2 times 6 rad 10 minus 4 rad 7. And I think where you're going to see this kind of get a little nasty is towards the end. I'm going to distribute that in. That's going to be 24 rad 20, and I think this is the number you want to be looking at. And then from here, I'm going to multiply this in, so I get minus 16 rad 14. Well, I'm not done with this part yet. I need to reduce that, so that's 24 times, let's see, this is 4 and 5, so 2 rad 5 minus 16 rad 14. This is really 48 rad 5 minus 16 rad 14. That's 3 right here. This is 4. If I say 2 rad 3 times 5 rad 11 plus 12 rad 5, I believe this is going to be a little easier. I'm going to multiply that in. I got 6 rad 33 plus 24 rad 15. And I can't do anything to combine or reduce, so I'm done with that. With FOIL, it's the same process, except you're going to just do it twice. Just a piece of cake. If I say something like number 6 here, if I say rad 6 plus rad 3 times rad 3, or let's say rad 5 plus rad 2, I'm going to get rad 30 plus, rad 12 plus rad 15 plus rad 6. Now this 12 here, now you got to identify which ones can we simplify. That is 4 times 3, so this is rad 30 plus 2 rad 3 plus rad 15 plus rad 6. There you go. Let's go 2 rad 3 plus 4 rad 5 times rad 3 plus 6 rad 5. Multiply that in. 2 rad 3 times rad 3 is 2 rad 9 plus 12 rad 15. This is a 3 plus 4 rad 15 plus 24 rad 25. So let's see what we can simplify here. This is 3, so 3 times 2 is 6, plus, well, these two happen to match, right? They're both rad 15, so I've got 16 rad 15s, plus, well, 24 times rad 25 is 5, so 5 times 24 is 120, so I've got 126 plus 16 rad 15. Okay, next I want to introduce you into a concept known as conjugates. A conjugate is, well, you actually already know what conjugates are. They are, it's almost like difference of two squares almost, how they appear. And they are very important in this section because we use conjugates. Well, I won't get into that just yet. I'll show you what a conjugate is. If I tell you a conjugate is 12 minus rad 3, well, if I have 12 minus rad 3, its conjugate is 12 plus rad 3. All right, same terms but opposite symbols on the inside. So again, if I give you, say, rad 6 plus rad 7, its conjugate would be rad 6 minus rad 7. And these FOIL out in a very unique kind of way. I'm going to get 144 here. I'm going to get positive 12 rad 3. I'm going to get negative 12 rad 3, which are going to go away, and I get minus rad 9. So what I get is 144 minus rad 9. Well, rad 9 is 3. So I get 141 is my answer. The unique quality of conjugates is that they produce a number. All right, I don't get any crazy terms. I get a number. So what I get here is rad 36 We know that this and this are going to cancel, so I don't need to even write them. Minus rad 49, so I get 6 minus 7, which is -1. Let's do a harder conjugate. This would be, that was 1, that was 2. This is the number 3 conjugate, which is 4 rad 5 plus 2 rad 7 times 4 rad 5 minus 2 rad 7. So that's going to be 16 times, rad 25. That's going to cancel, minus 4 rad 49. So 16 times 5, well, that's 80 minus, that is 28. So 80 minus 28 is 52. Conjugates are used because one of the rules, at least it appears more in algebra than it does in calculus, is this idea of having to rationalize denominators. To rationalize a denominator means to make sure that you don't have certain things inside the denominator of a number. So rationalizing denominators. One of the things that you cannot have in the denominator, at least at this level, is a radical sign. So no rads in the denominator. So if I give you an example, if I say something like 2 over rad 5, all right, that's example 1. What I'm going to do is I'm going to multiply this fraction by a variation of 1 in order to get rid of that rad 5 on bottom. When I say a variation of 1, what I mean is I'm going to multiply it by rad 5 over rad 5, because when I reduce it, it becomes 1, right? So rad 5 times rad 5 is going to be rad 25, and then 2 rad 5 is 2 rad 5. Well, rad 25 is 5, so I get 2 rad 5 over 5. Okay, and we call that, and the reason why the number 1 is so important is because I don't want to change the dynamic of this number. So by multiplying it by some kind of variation of 1, I keep the problem as it is, and yet I make it more, I suppose, aesthetically pleasing, because the rad on bottom is gone. So if I had, say, 3 rad 6 over, let's say, rad 7, what I'm going to do is I'm going to multiply both top and bottom by rad 7, and what I get is 3 rad 42 over 7, and that's where I go. Okay, so if we do another one, if I have, say, 4 rad 11 over rad 3, I'm going to multiply both top and bottom by rad 3. To get something over 3, I get 4 times rad 33 over 3. All right? Okay, where do the conjugates come in? The conjugates come in with problems that look like this. If I have, say, 2 over 4 minus rad 7. Well, what I'm going to do is I'm going to multiply the top and bottom by the conjugate of 4 minus rad 7, which is 4 plus rad 7. Remember, a few minutes ago we realized that conjugates produce a number, which means that I will no longer have a radical on bottom. So let's go ahead and get the top here. This is 8 plus 2 rad 7, and this is 16 minus 7. So I get 8 plus 2 rad 7 over 9, and I'm done. Let's try another one. If I have, say, 11 minus 2 rad 3 over 5 plus 4 rad 6. Well, what I'm going to do is I'm going to multiply the top and bottom by 5 minus 4 rad 6. So let's take care of the bottom. We've got 25 minus, well, that is 16 times 6. The top, I'm going to FOIL that out. That becomes 55 minus 44 rad 6 minus 10 rad 3 plus 8 rad 18. This is going to get kind of nasty, but that's okay. The bottom, this is 96. 25 minus 96 is negative 71. This here is 9 and 2, so this is 3 rad 2, so 24 rad 2. So I've got 55, and I don't think there's any other way I can clean that up, so I have 55 minus 44 rad 6 minus 10 rad 3 plus 24 rad 2, all over negative 71. Okay? I think that just about does it with all of our conjugates and all that stuff. See ya.